Tartarus is a Maya-based tool that enables game environment artists to generate organic, maze-like environments. Created by Marissa Como and Christopher Gibson as a part of CIS 660's curriculum at the University of Pennsylvania.
In exploration games like Rust, open-world RPGs like Skyrim, and dungeon maps of any classic game, environment artists are responsible for creating branching paths that are connected by rooms and tight corridors. Many levels require connected paths that lead the player to some goal.
Tartarus provides game environment artists with a tool to generate organic, maze-like environments. A user inputs a plane that is subdivided and multi-cut how they see fit. We have supplied some example planes for the user to replicate. The user can use any combination of the parameters Tartarus provides. The user can select areas of the plane to be part of the maze floor. This feature allows for room, path, or single face selection. The user can generate paths between those selected areas. This ensures the player can fully navigate the area. If the user wishes to select additional areas for the floor, the user can select a minimum and maximum face area range. This will add faces between the selected face range to the maze floor. Given that this bounded algorithm can create inaccessible rooms, the user can manually select faces and add them to the solution path so that the player can access these rooms. The user can choose a smoothing constant to adjust how smooth the walls are, affecting how organic the maze looks. The user can choose an extrusion depth determining the height of the walls. After the user presses the Generate Maze button, the output mesh will highlight a path solution based on a combination of the shortest path algorithm, the bounded algorithm, and the manually selected faces. The middle image is an example of a mesh output in Maya that has been generated using the shortest path algorithm between selected faces, the bounded algorithm between a selected min and max range, and user-selected areas. The bottom image is an example of this environment imported into Unity Engine.
The tool is inspired by the Connect the Dots family of puzzles by Martin Loeffler et al. Image 1 depicts the process of randomly adding multicuts in subdivisions to a user-created plane. We chose to represent the faces in a user input plane as the dots in the Connect the Dots family of puzzles paper. Our bounded algorithm incorporates the paper's Connect the Unit dot algorithm by selecting faces between a user-selected minimum and maximum face area range. In the bounded algorithm using MEL scripts, the area of each face that has yet to be selected is calculated. The user adjusts the minimum and maximum face area sliders in the GUI. When the Generate Maze button is pressed, faces with area weights that are bounded by the user-selected minimum and maximum values are added to the maze floor. Image 2 depicts the results of the bounded algorithm. In the shortest path algorithm, using MEL scripts, the shortest path between currently selected faces is determined, and the faces in that area are added to the maze floor. The user can press the Find Path button multiple times to adjust the path output to their liking. Image 3 depicts the pathfinding capabilities of Tartarus, always choosing the shortest set of faces between the selected faces. The extrusion depth determines the height of the walls. The smoothing constant affects how smooth the walls will be, but does not affect the floor so that the player's walking surface remains flat. The fourth image depicts the results of an extrusion depth of 12 and a smoothing constant of 2.
The following is an overview of our workflow and results for an organic mesh. First, the user creates an input plane of any size with faces of any shape. Second, the user selects key areas they desire to be accessible and presses the Find Path button to create a path between the areas. This process involves experimentation to achieve an artist-directed output. Note the user can undo any changes to the mesh and maintain their previous state while using this tool, selecting and deselecting specific faces as they go. If the user notices there is a room that has been blocked, they simply undo their last step and shift select to add the necessary face to the maze floor and open the room. This image depicts the user's final environment output in Maya with a highlighted solution path.
To demonstrate the applications of this tool in level creation, we have created a walkthrough in Unity Engine. The winding paths and hidden rooms make for a robust exploration and first-person shooter experience.
An input plane with uniform face areas means the bounded algorithm does not apply. The shortest path between selected areas or manually selected faces is found.
To demonstrate the variety of applications for our output mesh, we created a river scene. While this tool is focused mostly on character-traversed environments, this scene shows that the output of Tartarus can be used for more.
Finally, a user can create rooms with paths between them. Notice that the input plane was uniform, but the smoothing constant allowed for a more organic room structure.
The final environment uses the room structure of the mesh to create a first-person scene with more segmented exploration. Note how the majority of the action occurs in these sectors, while the paths connecting them serve as a respite from activity.
In conclusion, Tartarus is a Maya-based tool that enables game environment artists to generate organic, maze-like environments with exciting possibilities.